Okay, hi Year 10. So this video is for the 5.2 level and we're going to have a look today at 5H parallel lines and perpendicular lines. So what you will need is you will need a worksheet that is out the front. If you haven't got that one, go and grab one. And your worksheet will start off with these notes here. So what we're going to have a look at is what it means for lines to be parallel. And for lines to be parallel, they have the same gradient. So I'm going to just highlight that formula on that sheet for you. Two lines are parallel if they have the same gradient. And what does that actually mean? Well, what you've been looking at recently is that the lines of a straight line, or the equation of a straight line, looks like this. Y equals mx plus b. Remember, m is the gradient. Remember that? And b is where our graph cuts the y-axis, and we call it the y-intercept. So if you have a look at these lines we've got over here, y equals 3x minus 1, 3x plus 3, and y is 3x minus 4. The number at the front of the x matches up with the m on our general equation form, y equals mx plus b. So the m on that first graph is 3. The m on our second graph is also 3, and the m on our third one is also 3. So what we say is those three lines have the same gradient. So that means they're parallel. So even without drawing those graphs, we can look at them and say they're parallel. Now, remembering what parallel means, if you have a look at the red, the green, and the blue line, which match the ones on your sheet, those three lines are parallel, which means they are the same distance apart and they never meet. So our first line up there, 3x minus 1, if you were to plot that, that's our green line there. Our 3x plus 3 is our red line, and our 3x minus 4 is our blue line. So even without drawing them, we knew they had the same gradient, but when we draw them, we can see also that they are parallel because they're the same distance apart. Now, on previous lessons, you had practiced drawing lines that look like y equals mx plus b, and we did that by finding where it cuts the y-axis and where it cuts the x-axis. So you could still do that for those and draw them, but today I'm more interested in us having a look at what is happening out the front of the x. Now what you'll also note, just on another bit of revision, is our first one, 3x minus 1, which is our green line, it cuts the y-axis at minus 1. So that minus 1 down there matches the minus 1 in the equation. The 3x plus 3, although it has a gradient of 3, should cut at 3. And that's our red line, and it cuts at 3. And our 3x minus 4, which also has a gradient of 3, is our blue line, and it's going to cut at minus 4. So that's what that tells us as well. But basically today we want to have a look at just the gradient. Okay, now let's have a look at the next part. Okay, so this is also on your sheet. And what it tells us is that two perpendicular lines, so let's think about what perpendicular is first. What does perpendicular mean to you? So perpendicular means something meets at 90 degrees. So when we were looking at shapes or triangles, 90 degrees was shown as a little square, and it just means we have one line that's vertical and one line that's horizontal, or if they're angled, the angle between them is 90 degrees. So we can look at equations of the form y equals mx plus b and decide if those lines are perpendicular, but it's doing a little bit of a play around with the m's in front of our lines. So the blue part here says, two perpendicular lines with gradients m1 and m2 satisfy this rule. One gradient, which is m1, times another gradient, which is m2, will equal minus 1. Or you could write it as this, m2 is minus 1 over m1. So let's have a look at what that means in terms of our two lines in the graph over here. Okay, so our green line has the equation y equals 2x minus 1, and the gradient of that line is 2. Now we're saying that this blue line here is perpendicular to the green line, and if you have a look where they meet, they would actually meet at 90 degrees, but I'm telling you that they do meet at 90 degrees. So what that will mean is if we have a look at the other gradient of that blue line there, our m is minus a half. So using the rule we had over there, if we call this top one M1 and this bottom one M2, our rule said if our lines are perpendicular, and I can write perpendicular like this for sure, if our lines are perpendicular, then one gradient times another gradient will equal -1. So let's try that. M1 was 2. Our second gradient is -1/2. If I multiply those, I get -1. So therefore my lines are perpendicular. But what you can actually do, which is a really nice shortcut, if I only had this equation here, y equals 2x minus 1, what would be the gradient of a perpendicular line? What I would do would be I would get my 2, I would pop it over number 1, and I'd pop a minus in front of it. That's basically what I'm doing to find the gradient of the perpendicular line. So if we have a look over here, it says equations of perpendicular parallel lines can be found by first finding the gradient m, and then we can substitute that into this equation. Let's have a look at what that actually means. Okay, if you have a look at example 24 on your sheet, and we're going to work through that one together. Okay, it says, decide if the graph of each pair of rules will be parallel, perpendicular, or neither. Now we are not going to graph these, we're going to have a look at the gradient. So if we have a look at our first graph here, our graph is already in the form of y equals mx plus b. So in this case, I can read off that my gradient is 1/2. So what I want to do is get this second graph, and I'll write it down here, 2y minus x equals 5. And I need to rearrange that equation so it's in this form here. So we're going to use our algebra. So step 1, I'm going to add x to both sides. So I end up with 2y equals, there we cancel, x plus 5 or 5 plus x. And now I have to get rid of this 2. So if I divide by 2 on this side, my 2 will be divided by 2 and I'll get 1. And if I divide each term over here by 2, I'll get my equation, which is in the form of y equals mx plus b. And I can read off my gradient. So what this is actually telling me, it's 1/2 x plus 5 over 2. So let's have a look at our gradients. If I highlight those, my first equation had a gradient of 1/2. This second equation that I've worked out in a new form has a gradient of 1/2. They're both the same. So what I can say is, therefore, lines are parallel because they have the same gradient. So I want you to copy that one down, and then we're going to do the same with the next one. Okay, so remember, everything needs to be in the form of y equals mx plus b. So our first equation is already in that form for part B. It's y equals minus 3x minus 8. Now don't forget, if I'm going too fast, just pause the video. In this case, our m is minus 3. We can read that one straight off. In our second graph, or our second equation, it's y equals 3x plus 1, and m is 1/3. So it looks like that possibly those are perpendicular. Let's just test. Is our first gradient times our second gradient equal to -1? We get minus 3 on 3, which is minus 1. So yes, therefore, perpendicular. Okay, it's because our gradients multiplied together, and I'll highlight those for you so you can see them, are equal to -1. So that's a nice test there. Let's have a look at C, and C is a little bit harder. If you have a look at those two graphs, neither of them are in the form of y equals mx plus b, so we're going to have to rearrange both of them. So I'm going to write that first one down. This is a little bit harder, and I need to rearrange it. So I want the y left on the left-hand side, so let's get rid of the 3x. Minusing 3x, minusing 3x. So 3x minus 3x is 0, so I'm left with 2y is equal to, now I'm going to put the minus 3x at the front, just because I know that I need that for that equation format. And now I've got 2 times y. The opposite of that is dividing by 2. Let's divide everything by 2. These cancel to 1. I've got 1y, or y is minus 3 over 2x minus 5 over 2. So what's my gradient of that line? m is minus 3 over 2. That's my first line. Let's look at our second one there. X minus y equals 2. So don't forget you can rewind this video or pause it if you need it. Here's my second equation. Now I need it in terms of y minus. Now what I'm going to do is, because I don't want to deal with a minus in front of the y, I'm going to do a little trick. I'm going to say plus y. And then I'm left with an x equals y plus 2. What I'm going to do, and you don't need to do it this way, you can do it by other means, but I'm going to now go take off 2, take off 2. So I get x take away 2 is equal to y. Where if I just write that the other way, y equals x take away 2. And that's the form of y equals mx plus b. Now that's basically saying there's a 1 out the front of there. So my m is equal to 1. So they're my two gradients of my two lines. This one here and this one here. Now if you look at that and what's happening there, they don't equal, so they're not parallel, but they are also not going to multiply to get me minus 1. So therefore, they're neither parallel nor perpendicular. So they're a good example of neither. So that will give you some work where you can actually now understand how to test for perpendicular and parallel. But what I want to also have a look at is this second example on your sheet, which is on the back page of your sheet. I apologise, I think you've got it written twice on your sheet, but we only need it once. So it's finding the equation of a parallel or perpendicular line. So a little bit of thinking involved here. Part A, it says find the equation of a line that is parallel to this line here and passes through 1, 9. Okay, remembering we want everything in the form of y equals mx plus b, and we can read off the m. Parallel means they have the same slope. Okay, so what that means is we want a line that has m equal to minus 2. So I'm going to write that in my equation. I want a line that looks like y equals minus 2x plus b. So we want that minus 2 in our line, but our line might have slid down a little bit or have moved up a bit from where this one is, and it must pass through 1, 9. It needs to go through 1, 9. So what you'll notice is in my equation here, I don't have a number for b yet, but I do have that it goes through 1, 9. So what I'm going to do is I'm going to put the point 1, 9 into my equation, remembering that x is the first number and y is the second. So if I place it into my equation where the where the y is, it becomes a 9. The minus 2 will stay there, times my x. My x is that 1, plus b. And this will allow me to find out what b is. So 9 is equal to minus 2 plus b. Let's get rid of the 2. Plus 2 plus 2, I get 11 is equal to b. I'm going to go and put that back into that equation and get y equals minus 2x plus 11. And that's my answer. Quite simple. Okay, that was A. Let's have a look at the second part. We want to find a line that is perpendicular to y equals 3/4 x minus 1. Okay, the m for that line is 3/4. If we have a line that's perpendicular, we want to have a line that says, well, that gradient times the other gradient equals minus 1. Let's see if we can work that out. If you remember how to do it, you're basically going to get that number, flip it upside down, and pop a negative in front of it. So it's going to be minus 4/3. Or you could multiply both sides by 4 and then divide by 3. That's my new gradient of the line perpendicular. So y will be minus 4/3 x minus 1. Oh, sorry, not minus 1, sorry, plus b, because it's got to be of the form y equals mx plus b. Nearly got it wrong. So there's our gradient, minus 4/3 of the perpendicular line. I need to find that b because it's got to go through the point. Go back to the equation here. 3 minus 2. And it's got to go through 3 minus 2. If 3 is my x and minus 2 is my y, I'm going to pop those in my equation. So my y becomes minus 2 equals minus 4/3 times my x, which is 3, plus my b. Let's neaten it up. minus 2 is, they can cancel, minus 4 plus b. We're nearly there. Let's add 4 to both sides. We're going to get 2 is equal to b. That goes back into this equation, and my new equation is minus 4/3 x plus 2. And that's your examples. You're going to go through and have a look at some of these in the textbook in the exercise that matches this, which is going to be, if I jump back into our OneNote, exercise 5H, and you're going to go to exercise 5H and look at the blue questions and do exactly what we did. If you're stuck, you're going to go back to the piece of paper that we just did our notes on and follow those. Thank you.